Let's quickly go over the agenda for today's session. First, we will provide an overview of the MultiMaster feature in IBM GKLM. Next, we will discuss its benefit we get by using this feature. Then, we will dive into the requirements and considerations before configuring MultiMaster. After that, we will demonstrate on how to set up MultiMaster cluster with a live demo. Following the demo, we will be covering the operations you can perform on the cluster for management and monitoring purposes with a live demo. Finally, we will conclude with the licensing impact of these solutions. Before starting with the actual agenda, let's quickly go through the GKLM product overview. IBM Security Guardium Key Lifecycle Manager is an encryption key management tool that centralizes, simplifies, and automates the key management process. It offers robust and security-rich key storage, key serving, and key lifecycle management for self-encrypting applications and solutions by using interoperability protocols including KMIP, IPP, and REST, and interfaces such as PKCS11. GKLM helps clients meet regulations such as PCI DSS, HIPAA by providing access control, key rotation, and other automated key lifecycle management processes. Let's move to the next slide. Let's quickly recap the last webinar session on achieving high availability and disaster recovery in GKLM using replication. We discussed various implementation strategies for HADR, including redundant systems, replication and failover, regular backups, and geographical redundancy. To achieve HADR, GKLM offers three mechanisms: backup and restore, replication, and MultiMaster, out of which backup and restore and replication was already covered in the last webinar. In this session, we will focus on the MultiMaster feature. These are the three strategies that GKLM provides for different situations. At high level, in backup and restore, GKLM provides a way to create a copy or backup of data. This is then stored at offsite, which can be used in case of disaster recovery to restore back the system. This is complete manual process and mainly aimed for disaster recovery and not for high availability. While in replication, it is done using automated processes. Data generated on master server is periodically backed up and sent to the clone server. This supports high availability partially. We say partially because clone servers operate in read-only mode, support uninterrupted key serving, and data can be created only on master server. This is also used for automated disaster recovery with the right development architecture. The third one is MultiMaster, which is automated. This supports real-time data synchronization in the DB2 HADR cluster and used for high availability fully and disaster recovery. We say high availability fully because all nodes in this can be used for read as well as write operations. Replication supports 2 to maximum 21 GKLM servers, while MultiMaster supports up to 4 GKLM servers. Complexity of backup and restore and replication feature is low. Replication needs one-time configuration, while MultiMaster is little complex and requires knowledge of DB2 HADR. MultiMaster is supported on a traditional version of GKLM installation, while backup and replication is supported on both traditional as well as container version. Let's look at the overview of MultiMaster feature. The MultiMaster feature allows multiple GKLM instances to work together in a cluster, which provides high availability, better performance, and disaster recovery capabilities. A MultiMaster cluster is an architecture where multiple GKLM instances handle requires simultaneously. Each instance in the cluster is capable of handling requests independently while keeping data synchronized across all nodes. DB2 high availability disaster recovery is used as an underlying feature that ensures data redundancy. HADR configuration is managed internally by IBM GKLM. DB2 HADR supports multiple standby databases in the MultiMaster setup. The use of MultiMaster feature in GKLM is critical for several key scenarios. We will go through it one by one. The benefit we get is first one is the high availability. MultiMaster setup ensures continuous operation by providing multiple active instances that can handle requests, reducing downtime and ensuring data is always accessible. Then we can have load balancing. Distributing workloads across multiple masters prevent any single instance from being overwhelmed, improving performance and reliability. Disaster recovery. With multiple active masters, the system can quickly switch to an alternative master in the event of failure, ensuring rapid recovery and minimal data loss. Large-scale deployments. For organization with extensive data management needs, a multi-master approach scales efficiently, handling large volume of transaction and data without bottlenecks. We can have redundancy. By having multiple master, redundancy is built into the system, ensuring that failure of one master does not compromise the entire system's functionality. We can achieve the enhanced security. Distributing the data management across multiple secure instances reduces the risk of single point of failure, enhancing overall system security. We can have compliance. Multi-master configuration can help meet regulatory requirements for data availability, integrity, and protection by ensuring continuous and secure data management. Moving to the next slide for the deployment architecture. A multi-master cluster is an advanced configuration method. The cluster consists of multiple GKLM servers. Each server is called master server. All the master servers point to a single data source that is configured for DB2 high availability disaster recovery. Multi-master cluster ensures real-time availability of the latest data to all the masters in the cluster. However, it involves specific installation requirements, additional configuration, and requires a specialized DB2 administrator skills. The minimal deployment of the multi-master cluster is with 2 master servers. The full deployment of multi-master cluster can include maximum of 4 master servers. HADR supports multiple standby databases in your GKLM multi-master setup. You can have one principal standby and up to 2 auxiliary standbys. DB2 high availability disaster recovery configuration is used to provide continuous data availability to all the master servers in a multi-master cluster. HADR protects against data loss by transmitting data changes from a source database called primary to a target database called standby. DB2 HADR supports 3 standby databases in your multi-master setup. One standby for high availability and other 2 standby for disaster recovery. Priorities are assigned to each of the standby database in the cluster. Standby with a higher priority is on that assumes the principal database role. When the primary database is unreachable from the standby master server, the database on the principal standby master servers receives any client or device request. If the database on the principal master server is also unreachable, then the database on the auxiliary standby master server supports the request. Before you set up IBM GKLM multi-master environment, we have some requirements and consideration to ensure a successful configuration. First is for the operating system and database requirements. Ensure that the master servers with primary and standby DB2 HDR database host systems have the same operating system version and a fixed pack levels. For a master server that is installed on a Linux operating system, ensure that DB2 kernel parameters are set. DB2 username and password must be same on all master servers of the GKLM cluster. Port requirements. Ensure that the agent port and HADR port that are used in MultiMaster configuration are not blocked by the firewall. Default agent port is 60015, which you can update through GUI. Default HADR port is 60030, which is assigned during the MultiMaster setup. It is also configurable. Ensure that KMIP, TLS, TCP and agent ports are not blocked for communication before you set up IBM GKLM for MultiMaster configuration. Third is for IP addresses to hostname mapping. Before you set up a MultiMaster cluster, ensure that the host file on the IBM Security Guardium Key Lifecycle Manager server contains the correct IP address, public or private, to host name mapping information. The mapping information of every HDR master server must be included in the host file. For DB2 HDR configuration, the host file on every HDR master server of the cluster must be up to date. Other requirements and consideration: IBM GKLM server that you want to add to a multi-master cluster must not contain any data. Adding of server with data results in loss of data that can be previously created. For IBM GKLM multi-master deployment, the cluster must contain a minimum of one primary master server and one standby master server. When you set up a multi-master cluster, the server from which you add a master server or a standby master server to the cluster becomes the primary master server. You must add at least one standby master server to the cluster before you add other master servers. Then we have server certificate must be created in IBM GKLM server before you add it to the cluster as the primary master. IBM GKLM multi-master cluster supports up to 3 standby master servers. When you add a standby master server to the cluster, the priority index value must be in the range of 1 to 3. Follow all the requirements and consideration for multi-master configuration, which is mentioned in the doc link. Now let's see what are steps involved in setting up a cluster. Here on the top side, we see steps involved. Blue boxes shows operations to be done on primary master server. You must install GKLM on the server which will be your primary master and on each standby servers we are adding. There are 3 main steps involved in setting up multi-master on primary master. Configure communication certificate, then configure multi-master, which is add standby server, and then the verification part of it. In configure communication certificate, we configure communication certificate so that primary master server can communicate on secure channel where data is transferred. Now let's see the steps. First, we create a communication certificate. Then we must add basic properties like hostname, GKLM username, password for the user, UI port of the master server which we are planning to add as a primary standby server. Then we have to enter advanced properties like HADR port, then the standby priority index. Then we have to accept the host certificate. Then we have to check the prerequisites where the master server performs some checks. Then we have a step called add a master, and then we can verify the master server and the HADR status. So let's move to the next topic, that is managing multi-master cluster. Here are some of the important operations which can be performed to manage a multi-master cluster. Modifying master details of a cluster. You can change IBM GKLM multi-master configuration, such as modifying master server details to meet your requirements. For example, you can update the IBM GKLM administrator password. The second is like promoting standby server to a primary server. If a primary master in the IBM GKLM multi-master cluster fails or become unavailable for some reason, then you can promote a standby master to primary server while you resolve the failure. Removing a master server from multi-master cluster. You can remove a master server which is no longer required in IBM GKLM multi-master cluster. You cannot delete primary master server of a cluster. You can delete a standby master server only if the cluster contains at least one more standby master server. Starting, stopping and restarting multi-master cluster. When troubleshooting performance or connectivity issues or applying significant changes that require the cluster to be shut down, you can stop and restart cluster using GKLM GUI or REST services. For starting the cluster, you have to execute start cluster script file to start the cluster when the multi-master cluster service is down. Managing a read-only multi-master cluster. So when the database of a primary master server is unreachable from the standby master servers, the multi-master cluster goes into read-only state. The multi-master section on the welcome page of a graphical user interface displays a warning or an error for a DB2 HDR status to indicate that the cluster is operating in a read-only mode. Recovering a multi-master cluster from a read-only state. When the primary database is unreachable from the standby master server, the cluster goes into read-only state. For the cluster to be back into healthy state, you must complete the HDR recovery actions. Request you to follow the documentations for the detailed steps. Maintenance mode of a multi-master cluster. So in maintenance mode, a multi-master cluster operates with restricted functionality. A cluster can get into the maintenance mode during the operations like DB2 password change and cluster restart. Then we have a breaking a multi-master cluster. If you want to change the data redundancy method or set up a fresh multi-master cluster, you need to break the existing multi-master cluster. This case will arise when removing of master server fails for some reason and you need to break the cluster. For breaking, you must run the utility to revert all the master servers to standalone servers. Moving to the next slide, which is monitoring multi-master cluster. So in multi-master cluster, it's crucial to monitor the health of the master servers and addresses any issues quickly to prevent business disruption. IBM GKLM includes features for monitoring the health status of all master servers in the cluster. This monitoring is essential for setting up and maintaining your multi-master environment, providing a detailed overview of the configuration and health through various monitoring components. We have an agent service. It monitors, collects status of IBM GKLM master servers in the cluster at specified intervals. Use service to monitor health status and configure IBM GKLM instances in a multi-master cluster. This service gets automatically installed in the server. Like any other service, you can start and stop this service. The agent monitoring service periodically checks whether agents in other IBM GKLM master server of the multi-master cluster are up and running. The notification service. The notification events gets generated periodically and checks the status of the GKLM HDR setup and the connectivity between the master servers. If the service finds a problem or something goes wrong, it sends a warning message. You can use an existing notification functionality such as REST service or a utility that takes the notification events as input and triggers email notifications. Notification events are generated based on certain scenarios that occur in a multi-master setup. The scenarios are like when your master or standby servers are down, email notification will be sent. If DB2 HDR setup is down on the primary or standby master server, then if the primary master server or the database of it gets unreachable from the standby master server, then the notification will get triggered. So there is no special licensing for HDR feature. Simply, if the data is encrypted and GKLM serves the encryption keys, then the server must be licensed. We will need basic install licenses for each server that serves keys. We need n number of basic install licenses for n number of servers in case of multi-master. Like if your multi-master cluster is having one primary server and three standby servers, then you will require four licenses, as the cluster is consist of four GKLM servers. With this, we come to an end of a session for implementing high availability and disaster recovery using multi-master.